So, hi James. I usually ask my guests what was the first line of Java, but in your case, I will have to ask a different question. So, how you start programming? In which language and when was it?
Um, ay, ay, ay. I started programming in 1969. I think the first programming, I'm not quite sure. The first programming language I learned was, I think it was Focal 5. It was either Focal 5 or PDP-8 assembler. I'm not sure which one I learned first.
Mm-hmm. And why you did it? I mean, you were just curious, or you had to do this because of school, or what was your road to the first line of code?
I was, in junior high school or middle school, as some places call it. And a friend of my dad said, you want to wander around the university and see what's there? Because we happened to live about 2 miles from the University of Calgary.
Mm-hmm.
So he took me on kind of a walk around tour. And when we went through the computer center, my head just exploded because it just seemed so freaking cool. And, I was not even a high school student at the time. But, I kept coming back, and I had figured out how to get into the data center library, read all kinds of stuff. I didn't have accounts on any machines, but I learned how to effectively break in, partly from dumpster diving and stealing people's account numbers. To use there was some standalone, what would be called these days personal computers that were PDP-8s.
Mm-hmm.
And they were all in rooms with combination locked doors. But the thing about combination locked doors is people standing around can watch other people type in the combination, and then you're in. And because it's a university and I was kind of a big person anyway, there's this sort of default assumption that if you act like you're supposed to be there, then they treat you like you're supposed to be there.
Okay. How old were you then?
I started when I was 13.
Oh, okay.
Yeah. When you're a teenager at that age, a little, you're much more, your sense of what's of right and wrong is sort of guided more by what's cool than what's legal.
Was it just cool for you, or the other kids also liked this university?
No, I was absolutely alone in this.
Okay. Yeah.
I was grew up in a place where high school revolved around sports, hockey, and skiing.
Okay. And you were fascinated by the computers, but how they look like? So were they like huge machines, or more like like something like the E10K from Sun, or more like the smaller Spark stations?
Oh, nothing was smaller than a refrigerator.
Okay.
And the big interesting machines like the big Flix machines and the Honeywell and CDC machines, they were all rooms filled with cabinets the size of a refrigerator.
Okay. And were you fascinated by the hardware or by the software?
Kind of both.
Mm-hmm.
More the software.
Mm-hmm.
One of the things that was kind of a driver for me, and this might sound a little odd, but as a kid, we had like absolutely zero money.
Mm-hmm.
So being able to buy like parts to do electronics experiments was completely impossible for me. I did a certain amount of dumpster diving for parts that people had thrown away. There was a phone company switching center that was a good place to find old relays.
Mm-hmm.
But when you're dumpster diving in the 60s for relays that are obsolete in the 60s, you're getting really old stuff.
Mm-hmm.
And so it was always just a kludge. And the nice thing about software for me at that time, or one of the nice things, was that it really consumed no resources. You didn't need bits of wire. You didn't need anything else like that. You could just write your program and you would get, it would play games with you or make pretty pictures or whatever you wanted.
Mm-hmm. But how you got your motivation? So were the movies or something? So, I mean, there should be some initial idea, no? Like, let's build something from electronics or spare parts. So how it happened? You were just generally interested in it, or?
I guess I always just loved building things.
Mm-hmm.
I remember having this sort of personal epiphany as a kid. Where, do you remember that there was a movie called The Day the Earth Stood Still?
Yes.
The one with Gort. And I thought Gort was really, really cool.
Mm-hmm.
And I wanted to build Gort.
Okay.
And, that was when I was like 9 or 10. Okay. And, my first attempt at that was getting tin cans from the garbage, cleaning them out, cutting them up, and, building sort of like the Gort skin thing. Mm-hmm. But it didn't take very long before I had this little epiphany that, it's not what's on the outside that matters. It's like, how do you make them think? How do you make them act? How do you make all that stuff happen? Mm-hmm. And so I was like, where's his brain?
Mm-hmm. Okay.
And of course, nobody had an answer for that because, this is, the 60s.
Okay.
So anything that kind of looked on that path, like it was on that path, just like fascinated me.
Okay. So I assume your first program had something to do with the brain, right? Or you tried at least to
No, I was just, I mean, I was happy to do really simple things like, plot functions or, games like Hangman or Solitaire.
So what was your first program? So what was it?
I don't remember.
Okay.
Various games were high on the list, but they were all really simple card games. But by the time I was 14, I was good enough that I had some friendships that I had struck up with some of the other students, and one of them worked for the physics department, and one of the projects there needed somebody who could write software. And by then I was not quite in high school yet, but for some reason or other, they hired me. and after that, I didn't have to like search for topics. I was just whatever they needed.
Oh, this was your first job. How old were you back then?
I was 14, maybe 15. My mom says I was 14.
Okay.
But you know, it was working for. There was a group that studied the interactions between the solar wind and the upper atmosphere.
Okay.
And they had a satellite called the ISIS-2. Mm-hmm. And, you know, they were getting streams of data coming in, and they were trying to turn those streams of data into pictures. Mm-hmm. So I got hired to help with that.
Okay. And which programming language? Which programming language was it?
For that, the majority of what I did was PDP-8 assembler.
Okay.
A fair amount of CDC 6400 assembler. Mm-hmm. A fair amount of Fortran.
Okay.
Strangely enough, a moderate amount of PL1.
Okay.
But the vast majority was assembler.
With 14. You were 14 years old.
Yeah.
That's remarkable. So how much time do you spend with computers? I mean, all your free time? Seems like, right?
Just about. You know, like all through high school, you know, at the end of school, I would walk over to the university. I'd be at the university until probably around midnight. I'd head home. Lots of days I actually would skip school. Mm-hmm. And I discovered later that my teachers were actually happy with that, and they were often covering for me.
Okay.
Because they had actually figured out what I was doing. Mm-hmm. And since it wasn't, you know,
yeah,
it wasn't shooting up heroin or something. They were actually pretty thrilled.
Mm-hmm. And you regret that time that you spent the whole time with computers, or you think this was the right way to go?
I had fun.
Yeah, perfect.
You know, I mean, it's hard to know if some other path would have turned out better. Mm-hmm. I was always really socially awkward. Didn't have a whole lot of friends. Mm-hmm. You know, I had some friends, but I had absolutely no interest in sports. Mm-hmm. They mystified me. I could not understand why any of them made any sense. I mean, I enjoyed skiing, but that was kind of a family thing.
Cross country skiing or downhill?
Downhill skiing.
Okay.
My grandparents had managed a ski resort. Mm-hmm. And you know, that whole side of my family had basically lived on a ski hill.
Okay, in Germany, skiing is even considered as a sport. So I mean,
oh yeah, I mean, one of my uncles was on the Canadian Olympic ski team.
Oh,
you know, so you know, when your family does it all the time, you know, it's something that you get into, and you know, I realized at an early age that there was no chance I was ever going to be as good at skiing as my grandmother.
Okay.
But I did like hanging out with her while skiing because she was like unbelievably graceful.
Okay. Nice. So, after working for the company, what you did then? I assume you spent university just coding all the time? And
yeah, pretty much. I had a lot of part-time jobs. Mm-hmm. They were all coding jobs.
And which languages at the university time? Still the same?
Well, it was a lot of assembler.
Okay.
PDP-8 towards the end in undergraduate is some some PDP-11 because the PDP-11s came out just in like my last year there. A lot of work on the CDC 6000 series and the Multics machines. Did a fair amount of Fortran and PL1 and Pascal.
Oh, Pascal, that's remarkable.
Yeah, well, and actually a surprising amount of work in Simula. I did a little bit of sort of maintenance work on this on the Simula compiler, and I got to really love Simula.
And there was no C?
Oh no, C didn't come out until, C didn't really hit the scene until when did I first use C? First used C in like 76.
Okay.
Or 75.
But this was your university time?
Yeah. Yeah, until 1975 or 1976 is when I first used C, but Simula predated C by a fair number of years, as did Pascal.
And what was your favorite language back then? Simula, I guess, right?
Yeah. I liked Simula a lot.
And Delphi or Delphi?
No, the Pascal I used was the original ETH Pascal compiler that had Worth's name all over the source code.
Okay, understood. And so after the university, so by the way, university, I think this is where you wrote Emacs, right?
Pardon?
You wrote Emacs at the university or after?
Well, so I wrote Emacs when I was in grad school.
Oh.
So I started at Carnegie Mellon in 77 and graduated in 83. And when I was at Carnegie Mellon in my first year or so, I was exposed to several versions of Emacs. There was the original one that was a collection of Tico macros, and that one only ever ran on like the PDP 10s and 20s. The one that I used the most was one that was written in Maclist by a guy named Bertie Greenberg, and it ran on the Multics machines. I did a consulting gig when I was in grad school to build a Pascal compiler for Multics.
Okay.
And I did that all using Bertie Greenberg's Emacs. And then after that, I was like so addicted to Emacs, and there was no Emacs that could run on Unix at all.
Okay.
So I wrote one in C. It was modeled mostly after the Multics Maclist one. This got me in trouble in various political circles because the one true Emacs was the one written in Tico, and the one with the MIT command set, and I had followed Bernie, and there was another sort of Emacs clone on the PDP-10 that was much higher performance because it was written in PDP-10 assembler. It was called Fine, F-I-N-E. Fine is not Emacs. And that one was used really heavily at Carnegie Mellon. But the guy who wrote it, Mike Kazar, did different key bindings. So the Unix Emacs that I did, its key bindings followed the fine key bindings because that's what everybody at CMU was used to.
Mm-hmm. And your Emacs became the most popular one?
Pardon?
Your Emacs port to Unix became the most popular one, or?
Yeah, well, it was really the only one.
Yeah.
Because the original MIT one was only ever going to run on machines that had this very peculiar implementation of Tico underneath it. The Multics version was never going to move off of Multics. The PP10 version that was done by Mike Kazar, it was done in PDP-10 assembler. Mm-hmm. And all those machines are long gone. Mm-hmm. Whereas C and Unix survived.
Mm-hmm. Oh, that's interesting. And how long after Emacs you joined Sun? So I think 10 years or something?
Well, not 10 years. I mean, the Emacs became sort of self-supporting, in that it was good enough that I only used it to edit it itself starting in, I think, 78, maybe 79.
Okay.
No, 78. And then I joined Sun in 84.
How you join it?
As an engineer.
Yeah, but I had the chat with Scott, and this was like Bill Joy Askew, right?
Oh yeah. Well, it wasn't quite a Bill Joy asked me. It was Bill Joy constantly asking me over and over and over again.
Okay.
meeting up with me at conferences, jumping up and down, waving his arms, and I was like, yeah. But it sort of had a weirder history than that because in 82 when Sun was founded, through a strange coincidence, me and another friend had lunch with Andy Bechtelsheim, just as he had signed the papers with Scott and Vinod to create the company. Mm-hmm. And I had some history with and like the Motorola 68000. And at the time, IBM was trying to convince me to join IBM. And their CPU technology was way ahead of what Motorola could do. And I was partially jazzed by what the IBM labs were building, and convinced that Andy and friends were going to get crushed. Which turned so I took this job at IBM. Well, it was this sort of weird thing where it was a job at IBM, kind of while I finished off the end of my PhD thesis, and was at Carnegie Mellon. Mm-hmm. And I got to witness firsthand how magnificent IBM is at screwing over beautiful ideas. And so then I just like
your ideas.
Well, not so much my ideas got screwed over as much as the research group at IBM Yorktown, who had built this really lovely processor chip called the ROMP, which eventually evolved to being like the PowerPC. How they had a beautiful architecture completely crushed by internal politics.
Okay. Big company.
Yeah, yeah. I was appalled.
Okay.
So then I went and joined, Bill and Andy and crew, and it's, had fun.
And you knew Bill, so as a developer, or just as a a figure as a Sun employee?
No, I had known him before. We were both very active in the Unix community. There was a period in the early '80s when ARPA was trying to decide what to push for the sort of most common OS for like research labs and that to use. And DEC, Digital Equipment Corporation, they were trying to get the universe to standardize on VMS. And I pretty much, I spent a lot of time lobbying, writing letters, doing tests, building prototypes, just generally lobbying on the fact of Unix, on the side of Unix within ARPA.
Okay.
And because Bill and friends had done BSD at Berkeley, and I started running early copies of BSD Unix at Carnegie Mellon. And one of the things I did was a multiprocessor port of BSD to a completely strange multiprocessor. So I got to know Bill and other folks at the at Berkeley, but we were more pen pals because we were a couple thousand miles apart.
Okay.
And email ruled our life.
And do you remember your very first day at Sun?
No.
No, because it is interesting story, because you started at Sun, and I think you started with the enterprise stuff, right? So you didn't start it with Java.
Well, I started doing some of the desktop stuff. I ended up, so I was involved in a bunch of the user interface and Windows servers work. I spent a ridiculous amount of time writing device drivers for various graphics devices.
And then you became bored, right? This is at least what...
No, I can't imagine ever having been bored at Sun. The whole Java thing didn't start by being bored as much as me and some friends sort of developed this feeling that Sun was missing out on stuff. And that was mostly people writing software that was outside of the normal universe of the computer science world. It was outside of what computer companies were doing, and we got really intrigued by things that people were putting into telephone handsets and VCRs and televisions and locomotives and elevators, and it was cool. And we thought Sun was missing something, and we agitated with Scott, and Scott said, okay, go spend some time finding out what there is to see.
Okay. That's interesting. So in that early days, you already saw the potential in, running Internet of Things, basically. Not Internet of Things, more like,
Yeah, well, the Internet of Things is literally what launched Java.
Yeah. And you saw the potential already, or you just wanted to play with hardware again?
No, it felt like the Internet of Things was already happening.
Okay.
When we looked at what people were doing with embedded processors in devices, they were doing it.
Mm-hmm.
But when we kind of did our wandering around to various folks, one of the things that kind of horrified us was that they were kind of reinventing a bunch of stuff
Mm-hmm.
that people in the computer science universe had spilled a lot of blood over figuring out the right ideas.
Mm-hmm.
And one of the core things was about how to build a network.
Mm-hmm.
I kept seeing people inventing new mechanisms of networking that were exactly like what somebody had done 10 or 15 years before. And it was already known, the dozen ways that it completely failed.
Yeah, but this is normal. It still happens.
Yeah. Yeah. But at the same time, there were a bunch of things that the computer electronics industry was doing that felt like there were things that the computer industry was ignoring.
Mm-hmm.
Like they had an absolute dedication to safety and reliability.
Mm-hmm.
That there wasn't even a debate.
Mm-hmm.
Whereas I knew that hardware engineers at Sun, if they could get a big enough performance increase, they would actually be okay with something that increased or decreased the mean time to fail.
Mm-hmm. And how you got the idea from the virtual machine? So you were inspired by, I don't know, some language or?
Well, the virtual machine idea was actually from a project that I had done years before.
Mm-hmm.
That turned out better than I had expected. And then when I started talking to people about issues that they were having, with sort of software practice, I went, oh, that thing I did like 5 years ago
Mm-hmm.
actually would save the day here.
What was it?
And so what that was that there was this computer company called Three Rivers Computer.
Mm-hmm.
They had built a desktop computer kind of like the Xerox Alto,
Mm-hmm.
and they were trying to sell it commercially. And Carnegie Mellon had bought a bunch of them, and they were mostly pretty nice machines.
Mm-hmm.
But the instruction set, so the company was almost entirely hardware engineers, and one of the things that they didn't want to do was write a bunch of software. They didn't want to write compilers. They didn't want to do any of that kind of stuff. And so they were kind of like, so what compiler can we get for free?
Okay.
So they went, oh, we can do the UCSD Pascal.
Mm-hmm.
And it came with this interpreted instruction set.
Mm-hmm.
And so I went, so then, we at CMU, we wrote a bunch of software that ran on the PERC.
Mm-hmm.
And, but the company failed. And we had lots and lots of software that ran on the PERC.
Mm-hmm.
And it was just going to die, so my advisor at the time said, can you figure out a way to get this to run on like a VAX.
Mm-hmm.
And I think what he had in mind was like writing a Pascal compiler that was compatible with the PERC instruction set.
Okay.
Or that was compatible with PERC Pascal but would generate code for the VAX. But there were a couple of other languages besides Pascal, notably things like a couple flavors of Lisp. And I was too lazy to do a whole bunch of compilers.
Okay. You are a developer, so this is normal.
Yeah, this is normal, right? So I have this sort of gut thing about searching for the smallest solution. Mm-hmm. And so I kind of realized that I could probably take the PERC bytecodes and translate them into VAX assembly code. Mm-hmm. And lo and behold, that worked. But it didn't just work; it worked really well. And so I started doing benchmarks, and I realized that the performance I was getting from transcoding PERC bytecodes into VAX assembler was better than the C compiler, and fairly significantly. Mm-hmm. And so I spent a bunch of time thinking about, so why was it that this worked so well, and what would I need to do to sort of generalize it, and generalize it both for like different kinds of machines in that, because there was a lot of discussions going on about having an architecture neutral distribution format. And I sort of thought about doing that as like a PhD thesis topic. But my advisors, they said, no, getting that through the PhD thesis process would be really, really hard. Mm-hmm. So I sort of gave up on it. But the fact that it worked way better than I thought. So when time came, when I was on this sort of IoT project at Sun, mm-hmm. one of the things that kept coming up was that all the manufacturers of devices, they wanted to be able to treat CPU chips the way they treated any other part, like as commodities. Mm-hmm. So they wanted to be able to, if Intel was screwing them over, they wanted to be able to switch to MIPS quickly and easily. Mm-hmm. And they wanted, so that involves a whole lot of things about being really independent of the system architecture all the way through, having a language spec that doesn't have any undefined clauses.
Yeah.
One that actually tells you what arithmetic means.
Yeah. When you started at JavaSoft with or in the IoT project later, I guess it was JavaSoft. How long did it took to have a prototype in Java or Oak? You remember that?
So the project started at the beginning of 91, mm-hmm. and the first project, the Green project, mm-hmm. started at the beginning of 91, and it ended in September of 92.
Oh, remarkable! And you had something running already, right? In one.
Oh year. Yeah. So Java was running at the end of 91.
Okay. So
and we were using it to build this prototype.
Mm-hmm. So it was. Yeah. How quick was it until something was bootable? So you remember that it was month 2. I mean, the project took 1 year, but I assume you had something earlier, right?
Yeah, the earliest Java compiler took a couple of months.
Mm-hmm.
It was, I originally did it using Bison.
Mm-hmm.
And the code generator was pretty straightforward. And I decided to be lazy at the time and just do an interpreter. Because one of the things that I realized from even though the goal was generating machine code, one way to think about an intermediate format was as something that was meant to be an instruction set itself, and to get away from thinking about like encodings of parse trees and stuff like that, because from a sort of a the Java bytecodes are really like a Polish notation, and so you can think of them as something that is an execution of on a stack machine, or they're a reverse Polish encoding of a parse tree. And you can write down semantic definitions easier from the point of view of the stack machine, even though when you finally go to generate code, you're probably going to turn it into a parse tree and start doing algebra on the parse tree.
And was it a good decision, you think?
Yeah, it worked really, really well. I'm pretty happy with it.
Yeah, cool. So then, after 1 year, you had a project Green, and then I guess Oak. So Oak was just the language of Green, right?
Right. And, it was named because that's what was growing outside my window.
Yeah.
And, at the end of the Green project, we kind of had this like come to Jesus with, Scott and company. And it was like, well, could we do something actually useful with this? And we had gotten enough really positive feedback from people outside of Sun that Scott decided to fund us, trying to see what out of this that we could turn into a business, and that turned into First Person, which became this rather bizarre exploration of the cable TV and telephone industry. So there was kind of two parts to it, right? There was the evolving the technology, and then trying to do the business side of it, of working with the cable companies and the phone companies, and that was just psychotically crazy.
Yeah.
Working with those companies was just completely nuts.
Yeah. And the renaming from Oak to Java, was it marketing or more legal reasons?
It was legal reasons.
Okay.
We wanted to call it Oak. If you're going to release something, you need to use a name for it that's not going to cause you to get sued. Right. So if you try to release a compiler for a language called Coca-Cola,
it's going to be hard.
It's going to be hard because lawyers will arrive on your door.
Yeah. Oracle would be safer, I think.
Yeah. But so you really have to talk to some trademark lawyers and find out what you can do. And they did all the usual searches to see if we could use the name Oak. They basically screamed in horror at how bad it was. Then everybody started this like 5 or 6 month argument over what the name ought to be. and pretty much anything that sounded right, was already taken. We ended up, kind of in a panic because we weren't able to find a name, where we just locked a bunch of us in a room. We started yelling words. They got put up, and they were pretty random, and just ended up saying, well, which do you like, A or better or B? And so we ended up with kind of a sorted list. And then we handed the list off to the lawyers and said, go from top to bottom. The first one that makes you happy legally, we're going with whatever it is.
Yeah, so it's surprising that Java is worked for you, right? Because it's yeah. And actually, do you like coffee?
Oh yeah.
Oh, very good. So I was already, concerned that you prefer tea, but yeah, we are developers, so.
Well, I like tea too.
Okay.
I'm an equal opportunity kind of guy.
Okay, cool. So you spent some time at Sun Microsystems, and I guess you enjoyed the time, right?
Oh yeah. I mean, there's the usual stupid human tricks and politics in that, but Sun was fundamentally a wonderful place to be.
Yeah, this is what I hear over and over again. This is one of the reasons why I wanted to talk with Scott and with you about the old times and how it actually happened, because it was a remarkable place. I just observed everything from outside, but I really enjoyed every minute of Java One, and the whole interactions. They were really nice. And Scott, John Gage was already really. John was also involved in Java, right, from the beginning.
Yeah, as kind of marketing and cheerleader in chief.
Okay.
John's an interesting guy. Mm-hmm. It's not really possible to hire John and ask him to do something. Mm-hmm. What you have to do is figure out what John is passionate about. If it happens to be something that's useful, then hire him. But fundamentally, he listens to his own drummer.
Oh, interesting. What also interests me is actually Genie. So the Java Intelligent Network infrastructure. It was like a few years after Java started. I think it was like 96 or 97. And Bill Joy played a huge role. And what I never understood was how bad the marketing actually from Genie was, because the technology was brilliant. So right now it could be microservices, it could be service-oriented architecture, self-healing networks. So it was actually alone the idea of leasing, where the resources can disappear and reappear, was genius. It was very simple, and actually inversion of control as well. And it was genius back then. And but in Germany there was like conference. They say Genie is great, for distributing printer drivers, and say but it could be also used for load balancing of enterprise services, right? And and this was like a strange situation, because the technology was actually way better than the marketing was.
Oh yeah, well, and part of the problem with the marketing was that companies like Microsoft and Microsoft basically pumped an infinite amount of money into marketing XML and SOA. Mm-hmm. And one of the things that sort of characterized Sun was that Scott really doesn't like to spend money on marketing.
Okay.
Even if somebody is, fighting you tooth and nail, his preference is more to kind of let it bubble up from the bottom, let developers choose.
Mm-hmm.
And that works fine, except when, people are being bamboozled and so the whole Genie thing and the underlying technology for it, RMI, was just a travesty.
Okay.
And RMI was kind of a precursor in that, there was this huge fight between RMI and the object management group.
Corba, yes.
And Corba. Mm-hmm. And all the engineers would pick RMI.
Yes.
And all of the senior executives would pick Corba.
Yeah.
Because I have a problem here, which is that we're at the end of the hour.
Okay.
I've got a next thing. So do you want to do a follow-up